Welcome back to the deep dive. Today, we're taking a really close look at a brand that gets a lot of respect, especially from RC builders focused on restoring those classic kits. We're talking about Hudy. And our mission here is to kind of dig deeper than just the price tag. We want to understand why they have this reputation. We're going to explore the history of the Slovakian company and really analyze how their tools and those specialized lubricants, the Chem series, actually offer, real benefits, especially for protecting iconic vintage Tamiya kits, stuff like the Hornet, the Bruiser, the Avante.
Exactly. And for you listening, have you ever looked at a Hudy hex driver and thought, why is this so expensive?
Yeah.
Well, the answer starts way back. The core idea from our sources is that Hudy's status isn't just clever marketing. It really comes down to the unique history of the founder, Juraj Hudy, and how necessity basically forced his design philosophy. This brand was literally forged behind the Iron Curtain out of scarcity.
Okay, let's unpack that history first. It sounds like an amazing story of just sheer engineering grit. It doesn't start in some fancy factory, right? It starts in former Czechoslovakia, needing to be totally self-reliant.
That's the heart of it. Juraj Hudy started out in slot car racing back in the 70s, designing, building his own winning cars. But then, around 1975, he moves into RC cars, and bam, politics gets in the way. The communist regime banned Western imports.
So no Tamiya kits, no Kyosho, nothing.
Nothing. No parts, no tools. The sources say the feeling was stark. The only chance was to produce your own RC car. It wasn't just a hobby choice. It was like, if you want to race, you have to build it from scratch.
And the scale of that is what gets me. They weren't just making car parts. They had to make the machines to make the parts, all in a tiny workshop.
Yeah, a tiny 9-square-meter workshop. Think about that. It's smaller than a lot of garden sheds. And in there, he's not just making the chassis or handling epoxy bodies. He had to figure out how to make the tools, the lathes, the custom equipment first, just so he could then make the car components. He had to be a tool maker before he could be a car builder.
That's incredible. The fact that political isolation forced them to basically bootstrap their own manufacturing capability, that's wild. And yet they innovated incredibly quickly despite all that.
Astonishingly fast, yeah. By 1977, he's making these sophisticated chassis plates from 4mm duraluminum. That's a high-strength aircraft alloy.
Yeah.
Then jump to 1984. He develops one of the first competitive 4WD nitro cars in the region. And it's using modern drive shafts, even a front one-way differential.
Which was pretty cutting-edge stuff for the mid-'80s anywhere, let alone working in isolation like that.
Absolutely. He wasn't copying kits. He was engineering solutions from first principles. By 86, 87, his designs had fully enclosed gearboxes, keeps the dirt out, and even automatic 2-speed transmissions. All driven by this minimalist approach because, resources were scarce.
Okay, so this intense period of forced innovation sets the stage. Then 1989 happens, the political situation changes. Hudy goes from this clandestine workshop to a proper company. And then comes a huge moment in 1990, the partnership with Serpent.
Yeah, the Dutch RC giant.
Yeah.
That partnership was huge validation. Serpent saw the quality, the precision of Hudy's parts, and basically contracted him on the spot to become an OEM supplier.
OEM, so making parts for Serpent's own cars.
Exactly. High-precision transmission parts, specifically for Serpent's global market. And meeting that demand, that Western standard, meant Hudy had to really formalize everything. This pressure, this need for industrial-level quality control is what led them to develop what they call their top-secret self-developed formula for making super durable parts and tools from this special spring steel. That long OEM relationship really built Hudy's reputation as a serious manufacturer way before most RC builders even knew the Hudy name on a tool.
Okay, that history makes perfect sense now. Necessity really did breed quality. So let's look at the tools themselves. People call them a long-term investment, even mechanical insurance for vintage builds. But honestly, lots of tool companies talk about special steel. Is Hudy really different from other high-end brands?
That's a fair question. It's not just about hardness, though they are hard. The key difference is elasticity. We need to talk about this proprietary spring steel they use for the tool tips.
Spring steel. Okay.
Right. Normal hardened steel can be brittle. Spring steel, though, it's defined by having really high elasticity and yield strength. It can flex slightly under load and return to its original shape.
Okay, practically speaking, what does that mean when I'm trying to crack loose a 30-year-old hex screw-on, say, a Tamiya Frog gearbox that might be seized up?
It means the tool tip isn't brittle. That tiny bit of microscopic torsional flex acts like a shock absorber. When you put sudden torque on a stuck screw, a standard super rigid driver tip can just instantly transfer all that force, and that's when the driver cams out.
Right, cam out. Can we quickly define that for anyone newer to this?
Sure thing. Cam out is basically when the hex driver tip slips out of the hex socket in the screw head, usually rounding out the inside of the screw head as it does. It just chews it up.
Ah, the dreaded strip screw head. Especially bad on old Tamiyas with softer screws.
Exactly. That little bit of flex in the Hudy spring steel tip absorbs that initial shockwave of force. It prevents that sudden slip, gives you that crucial moment to break the screw loose without shearing the head or rounding it out.
Okay, that is a tangible benefit. The tool gives just enough to save the irreplaceable fastener. I get it. Now, what about the handles? They're CNC machined aluminum, right? 7075T6 and hollow. Why that specific stuff?
Yeah, that choice is very deliberate. 7075T6 isn't just any aluminum, it's aerospace grade. Super strong, used in aircraft frames. But it's also light.
Lighter than steel, obviously.
Yeah. Much lighter. If the handles were solid steel, they'd be heavy, and your hand would get tired during those long builds. Think about assembling a bruiser or an Avante that takes hours. So they used this lightweight, hollow 7075 T6 handle, but they made it to that super strong spring steel shaft and tip. All the strength is right where you need it, applying torque, but the overall tool is light and balanced. It's designed for performance and reducing user fatigue.
Smart. Strength where it counts, light everywhere else. And this performance is backed by crazy precision, right? What are the tolerances?
The numbers are pretty mind-blowing, yeah. Hudy holds tolerances within 5 microns. That's 5/1000ths of a millimeter.
Wow. So, like, compared to a human hair.
About a tenth the width of an average human hair. It's incredibly precise. And that precision means the tool fits the fastener perfectly. No slop. A tight fit distributes the turning force evenly across all 6 flats of the hex screw head instead of concentrating it on the corners, which is what leads to stripping.
Makes sense. Less wiggle room, less chance of damage. And quickly, before we move to lubes, for the serious builders, maybe restoring an Avante to race it, the Hudy setup station.
Oh yeah, that's considered the gold standard by many.
It
It
was-
lets you precisely measure and adjust all your suspension geometry, camber, caster, toe. Uses high-grade aluminum parts and 12 super precise ball bearings for smooth, accurate readings. Takes all the guesswork out of setup.
Okay, history covered, tools covered. Let's switch to the chemistry side. The Chem Series lubricants. For someone working on vintage Tamiya, what's the absolute biggest worry when it comes to lubrication? It's not just about reducing friction, is it?
No, not at all. The number one concern is material safety. Long-term preservation. You've got those old kits with soft, often white nylon gears. Think Grasshopper, Lunchbox, Hornet gear brakes, and also EBS plastics.
Right, the plastics can be sensitive.
Very. Petroleum-based greases, the kind you might find in a hardware store, can actually damage those polymers over time. They can cause swelling, softening, or make them brittle and prone to cracking. The absolute consensus among restorers is you need silicone-based greases. They're chemically inert. They won't react with or degrade those vintage plastics.
So silicone is the key. And Hudy's range is designed as a system, right? Takes the guesswork out. Let's run through the main ones, like an application guide for someone listening.
Okay, let's do it. Start simple.
Yeah.
Those open plastic and nylon gears like in the Grasshopper or Hornet gearbox. For that, you want Hudy diff grease. Hashtag 106211.
Diff grease on simple plastic gears.
Yeah. Despite the name, it's perfect here. It's silicone-based, totally plastic safe. Plus, it's got this really tacky consistency.
Yeah.
It clings to the gers and doesn't just get flung off at high speeds like some thinner greases might. And it resists water way better than the stuff Tamiya originally included.
Okay, plastic safe, water resistant, tacky. Sounds good. But if it's good for plastic, why not just use it everywhere? What about, say, the metal gears in a Bruiser's 3-speed?
Ah, right. For serious metal-on-metal contact, especially under high load like in that Bruiser transmission, you need more protection. You need extreme pressure additives. That's where Hudy graphite grease, hashtag 106210, comes in. This one's different. It contains EP additives and also graphite, which is a solid lubricant. Think of the graphite particles as tiny buffers between the metal surfaces under intense pressure. It's the best choice for things like metal bevel gears, universal joints, CVDs. It's basically Hudy's high-performance version of the classic Tamiya molybdenum grease.
Gotcha. Graphite for heavy metal. Okay, moving up the complexity ladder. Ball differentials, like in the Avante or Egress. They work using friction, right? So that needs something totally different again.
Totally different, yes. A ball diff needs controlled slip, consistent friction between the plates and balls. For that, you absolutely need Hudy Super Diff grease, hashtag 106212. This stuff is thick silicone grease, really high viscosity, Very tacky. It coats the diff plates and the thrust bearing, providing that consistent friction needed for the limited slip action, and it handles the huge clamping force when you tighten that diff down. Using anything else will likely make the diff inconsistent or just slip.
Okay, thick stuff for ball diffs, and one last specific one that seems crucial, the one-way bearing, like in the front of the Avante.
Yes, this is a classic gotcha moment for builders if they use the wrong stuff. A one-way bearing has tiny rollers or sprags inside that need to move freely to engage and disengage.
So grease would gum it up.
Instantly. Any thick grease, even silicone grease, will clog the mechanism and it'll just slip constantly or fail to engage. For one-way bearings, you must use a very thin oil. Hudy makes Hudy one-way bearing oil, #106231, specifically for this. It's super thin, penetrates easily, and lets the bearing work correctly.
Okay, this really paints a complete picture. The tools are about protecting the parts during the build, and the lubes are about protecting them chemically for the long haul.
It's a whole system, exactly. Hudy's quality isn't accidental. It comes from applying proper industrial chemistry, synthetic oils, lithium thickeners, and that precision engineering we talked about.
Mm.
And it all traces back to that history of having to figure it out themselves because they had no other choice.
So, wrapping this up for our listener who's maybe restoring their childhood Tamiya, what's the essential Hudy investment strategy? What gives the biggest bang for the buck in terms of preservation?
Right, focus on protection. Think of it like this. If you strip one rare screw on an original Avante chassis plate because you used a cheap driver, finding and buying a replacement screw, if you even can, might cost 10 times more than the proper Hudy driver would have.
Good point. So, specific recommendations.
Get the 3 essential greases. The diff grease, 106211 for plastics. The graphite grease, 106221 for metal on metal. And the super diff grease, 106212 if you have ball diffs. That covers almost everything. And for tools, absolutely get the core Hudy hex drivers in the common Tamiya sizes, 1.5 millimeters, 2.0 meters, and 2.5 millimeter. That's your mechanical insurance policy. You know, the whole Hudy story, it shows how being forced into isolation actually pushed them to achieve this really high level of technical quality that later became a world standard. That makes you wonder, doesn't it?
Wonder what?
Well, today we have global supply chains, cheap tools readily available everywhere, but does that abundance maybe lead to compromises? The Hudy story suggests that maybe real, durable engineering precision. Maybe that only truly emerges when necessity both for the builder and the engineer is absolute. Something to think about next time you're working on your own vintage treasure.